Okay, so now I'll delve into the details of the five preparatory steps. So here you go. This is step 1 and step 2. As you can see, hope I'm not hindering the board. So here, step 1, as you already wrote down on your paper, yeah, 1 glucose will be converted to glucose 6-phosphate with the help of hexokinase enzyme and the environment that contain magnesium 2+. Alright, I want to explain in very deep details. So here is a molecules of glucose. Okay, and what happens here is that you want to add a phosphate group into these glucose molecules. And to do so, you need an enzyme called kinase. Kinase. So the word kinase means what? Ase is an enzyme. Kine is kinetic. Kinetic or movement. Kinetics or movement. So it's like kinase is an enzyme that will add a phosphate group into something. So in other way, kinase, it will help the phosphorylation of something. Wait a moment, phosphorylation. So phosphorylation is where it's the adding of phosphate group into something. So in other words, I could say the kinase enzyme will help a molecule to undergo phosphorylation. Okay, kinase. In this case, hex, in the Greek numbering system, what is it Greek? Oh yeah, mono, duo, duo, tetra, penta, hexa, hepta, octa, nona, deca. Basically, that's how the Greek system of numbering works. So this enzyme will help the kinetics of the molecule that contains 6 carbon. Hexo, there you go. Okay, in other words, this enzyme will help the phosphorylation or adding a phosphate group into the molecule that contains 6 carbon. In this case, it's a glucose. So that's how the name can be derived, hexokinase. Okay, that's how the name can be understood, hexokinase. And you need the environment to contain magnesium 2+ as well. So what happens here? Who will give the phosphate group? Nothing else than the ATP, which is the energy molecule of the cell. It's like we human, we eat for energy, right? But for the cell, they require ATP as energy to work. So the ATP, this adenosine triphosphate, it has 3 phosphate groups to begin with. And when they give up one phosphorus in there, phosphate group in there, they become adenosine they will become diadenosine become di. So adenosine diphosphate. So they lose one phosphate, become diphosphate. There you go. So when ATP loses a phosphate group, it becomes ADP, which is like a use up battery. So ATP is like energizer battery. ADP is like use up battery. And of course, you can kind of recharge this battery as well. You will see later. Okay. So this one give one phosphate group in there, PO3 2- in there. So you can see one H will be removed, and it will become a H+. We call them a proton, H+. So what would happen to this H+? H+ will not just be there for free, in the cytosol, because H+ is acidic. It's not good to have more acid in the cell when this thing happens. So it must be trapped. It must be carried by a molecule called NAD. NAD. I'll talk more about it later, okay? but the NAD will capture the H and it will become NADH. The NAD, the NAD, will capture the H plus and become NADH. I'll explain further about that later. Okay. But anyway, I already explained step 1, how this thing can be formed, okay? Step 2 involves turning the glucose 6-phosphate into a fructose 6-phosphate. And then you know glucose and fructose are isomer of each other. So glucose and aldose is a sugar that contains aldehyde group. And fructose is a ketose, which is the sugar that contains ketone group. But they're isomer of each other. So you need an enzyme to convert them into isomer form. So the enzyme will be called isomerase. That work on a glucose molecule that has a phosphate group there. You can see they name the enzyme according to the substrate that it acts on. Okay, and then okay, I already numbered the carbon for you to be able to see easily. Carbon 1, 2, 3, 4, 5, and 6. So what happens here is the enzyme is going to act to remove this first carbon. No, it doesn't remove, it just move it up. And when this first carbon move up to here, it causes the oxygen and the carbon number 2 to meet up, so like this. Okay, so this one goes up and these two meets up. The other thing doesn't change. Alright, you might ask me why I draw this one to the right but this one is on the left. Basically they're the same thing, I just don't want them to look like, you know, clumped together here, so that's why I draw them to the left. They're still the same thing, don't worry. Okay, so you have fructose 6-phosphate as a result. That is the end of step 2.